So, good morning, everyone. Today we are going to start our session on cloud computing. Just give me a second. What I'd like us to do is introduce the subject in as far as what cloud computing and serverless architectures is. And maybe before I start, we could maybe have some of us give feedback concerning yesterday's training, whether you think the format is okay and whether there are any challenges that you faced, so that we can be able to make amends and work towards making the experience better. So the floor is open.
Good morning, everyone.
Morning.
Okay, maybe just for my feedback, I like the format for training. I think yesterday's session was very informative. It was a good introduction. We actually went on to the e-learning platform and did the quiz. So I think the pace at which it was going was okay for me. And so far, I'm enjoying the training.
Okay, anyone else?
Tom, for today, I think we'll need a short break before the end of, before 1 o'clock.
Midway. Okay.
Somewhere, yes.
Yeah, we'll adhere to that. Okay, so I think we can start the session unless there is anyone else who's wants to share his or her feedback.
Okay, Tom, mine is a quick reminder that we need to go to the e-learning platform and create an account there and join the program. All the presentations, the quizzes will be sent there. Thanks.
Okay. Yeah, that's very important that we ensure that we do the quizzes and the questions that are there. So let's start. Cloud computing and serverless architectures. Depending on who you ask, there are many people who will tell you what cloud computing is, and majority of them will immediately start talking to you about the dangers or the disadvantages of cloud computing. And this, as we saw yesterday in the technology hype curve, is as a result of the negative publicity that it had initially received. And as we've seen, all technologies always, before they become popular, always have a phase where the publicity of that technology is negative. And I gave an example of 5G. There's a lot of talk around that 5G is responsible for causing COVID and brain tumors and all that. But as we know, okay, as far as I know, that's not really the case. And the same thing came for cloud computing. When it initially came, there was a lot of negative publicity. And if you look at the negative publicity that was there, was mostly from the businesses that were afraid of losing a market share, that is the hardware suppliers, like where you go buy a server. And that wasn't even the biggest objection to cloud computing. The biggest objection was from the IT sector itself, the IT managers themselves, who felt that they will lose some form of control and authority. The truth is that in most offices, most people want to look busy and important. And what happens is that if you have a server room full of racks and servers and humming and crunching all the company data, all of a sudden that is no longer going to be there, and it's going to the cloud. So of course there was a lot of opposition from IT managers and IT personnel in terms of the cloud not being an option for most organizations. But in the last 5 years or so, we've seen a dramatic change and embracing of the cloud by many organizations, big and small. It's unthinkable today for an organization to buy a physical server when the cloud exists. And we'll see later why. And the economies of scale and the benefits that cloud provides are so immense, and only a fool can ignore them. And I say only a fool because later in the training, we'll see how we can have a server up and running within 5 minutes. And by tomorrow this time, that server will have costed us about 20 shillings to run. For you to do the same thing with a physical server, you would need to buy a server that will cost you anywhere between 300,000 shillings. You would need to get somebody to configure it. You need to buy the licensing of the software inside the server. You would need to rack it up in a server room that has its environment controlled in terms of temperature and access and all that. So if we set out 2 people to set up a server, one physical in the office and another one on the cloud, the guy setting up on the cloud will be done with. The guy setting it up on the on-prem space would need a week, assuming their procurement processes are faster than most organizations, driving us towards a zero marginal cost society or economy. And it's true. I've just given an example. 20 shillings vis-a-vis 300 to 500,000 shillings. So the upfront costs are no longer a barrier to entry to many organizations to embrace the cloud and use computing resources on the cloud to innovate and provide products and services. So that's the advantage. So we'll start by defining what cloud computing is. And cloud computing is a model for enabling ubiquitous, convenient, and on-demand access to shared pool of configurable computing resources. And this is mostly done over the internet. And the main key advantage of that is that these resources are used on a pay-per-use basis. The billing is on a pay-per-use. You only pay for what you consume, and this has turned the tables as far as accessing computing resources is concerned. And by pay-per-use, I mean that if you're running a service on the cloud, if you have set up a server on the cloud or a service, as we'll see later, we can do, we do not need even to set up servers on the cloud. You pay only for the time that you use that cloud service. It's not a lease that you have a lease, you've leased a server somewhere on the cloud and that server is yours. You are paying for the compute and storage resources that are on the cloud. Yeah. So, but then the other question that comes in is, what is the cloud then? Yeah. The other day when we were working from home, we saw very many people sharing memes on social media about them being able to see Mount Kenya from Westlands or something. Some were making a joke of it and taking a picture of the sky and saying, "Oh, we can see our cloud hosted files on the cloud, thanks to the environment clearing up." So that was a joke that was being shared online. But what is the cloud then? The cloud is simply computing and storage services that are hosted in massive data centers and are available for access and use. Now, I'd like us to watch a brief video of what cloud computing is, and maybe see what inside a cloud data center looks like, and what is involved in providing cloud services on a cloud data center. So you'll tell me whether they sound or not, so that we can adjust.
There's no sound.
There's no sound?
Yeah.
Sorry, just hold on. Let me share again. Sorry.
David Pogue of Yahoo Finance. That enigmatic entity storing our data on the internet. David Pogue of Yahoo Finance knows and tells all in our Sunday morning cover story.
These days, you can't walk through an airport, read a magazine, or open a computer without seeing ads for the cloud.
The cloud, where everyone can access everything they save from anywhere they are.
The ads clearly suggest that the cloud is desirable. But what they don't say is what the cloud is. Well, here's the basic idea. In the beginning, we all kept our own stuff on our own computers. In the new world of the cloud, though, your computer files don't have to be on your computer. They can be stored out on the internet, alongside everyone else's, in huge centralized buildings called data centers. Your computer or phone can then fetch your files on the spot, wherever you happen to be. Now, you may have encountered the cloud as a synchronizing service. For example, Apple's iCloud service. If I edit this photo on my Apple laptop, maybe make it black and white, maybe crop in on it, a couple of seconds later, I'll see the exact same changes show up on that photo on my Apple phone. Now, these two devices are not directly connected. Instead, that data made an intermediate hop. In a fraction of a second, it comes here to a massive data center, and then it returned to the phone. Most of the time, though, you use the cloud without knowing it. Because most of those cloud data centers exist to serve companies.
So it could be retail, it could be real estate, healthcare, life sciences, oil and gas, everything from small initial startups right through to the very, very largest enterprises.
Matt Wood is a general manager at Amazon Web Services, or AWS. It's by far the biggest cloud service company in the world, bigger than its next 14 competitors combined. So all of these industries, all of these companies are hiring AWS to do what?
Let's say you're a brewery. They want to brew beer. They don't want to manage computers. They want to brew beer. They don't want to be going through the expense and the upfront cost and all the complexity of managing these large amounts of computers.
What you're saying is that cloud companies like AWS are basically renting computers, storage, power, security, all the stuff that technicians would have normally had to do on site, right?
That's right, yeah. And so today, very large organizations such as GE, Shell, Philips, Netflix, all run on top of AWS.
If you'd like to see what the cloud looks like, all you have to do is visit a data center. like this one belonging to Raging Wire in Virginia. But good luck getting in.
This is a retinal scanner, and this one's kind of interesting because this one's smart enough to know whether my eyeball is alive or not. So that means you can't take another eyeball and hold it up to here.
Well, darn, 'cause I was sort of hoping to kill you and sneak in.
It's not going to work here.
Fortunately, marketing director Jim Leach agreed to give me a tour.
Oh, this is called a man trap. Man trap. And the secret here is that one door has to close and lock before the other door can open.
Once you get past the concrete barriers, the armed guards, the retina scanner, the man trap, and 9 password-protected doors, you find out what's inside a data center. Just racks and racks and racks of powerful computers. This is the internet.
This is the internet. This is the cloud. Basically, in this room, ballpark, there's about 3 million websites running right now.
For security reasons, they'll never tell you whose websites. But every site and app you've ever heard of, Facebook, Twitter, Netflix, Uber, Airbnb, the New York Times, even CBS News, lives in data center cages like this one. All right, I gotta ask, what happens in a power failure?
It's backed up by batteries that can run the entire facility for about 10 minutes while we turn on these massive generators that can run continuously.
This data center is in Loudoun County, Virginia, which turns out not to be much of a surprise.
70% of all web traffic on a daily basis from the world goes through a Loudoun County data center.
Come on!
70%.
Buddy Reiser is the county's head of business development. He's helped turn Loudoun County into the largest concentration of data centers in the world. 10 million square feet in 70 enormous buildings.
What do the data centers need and how do we provide it? And it comes down to power and water and fiber and workforce and proximity. And I think the other thing you need is plenty of green space to build, because these are really big buildings, as you can see.
But hold on a second. If we're concentrating all of our data into data centers and concentrating most of the data centers into one county, doesn't that make a very tempting target for terrorists? Amazon's Matt Wood isn't worried.
If something does happen, or we have a power event, or there's a flood in one specific location, that data is held redundantly in other locations as well. So
I don't mean to give anyone ideas, but let's say I figured out that one of these unmarked buildings was an AWS data center, and I blew it up. Are you saying that it's so backed up and redundant that probably you wouldn't notice?
yeah, you wouldn't notice. I mean, we might be a bit upset, but we wouldn't notice.
Okay, so the cloud offers speed, security, flexibility, and savings to the world's businesses. But that doesn't mean it's flawless.
A really obvious example is that the cloud uses a massive amount of power.
Tung-Wei Hu is a University of Michigan professor and author of A Prehistory of the Cloud.
Greenpeace calculated that if you added up all these data centers, they would be the 5th most power-hungry country in the world. They're idle 96% of the time, and the reason is because they're waiting for that.
What are?
Data centers are just computers sitting around doing nothing for 96% of the time. And that's because they're waiting for a spike in traffic. They're waiting for the next music video to go viral. It's those exceptional moments which they have to build a capacity for it. But most of the time, nothing really happens on the internet besides a lot of cat videos.
And then there's all the secrecy.
We don't know anything about what Amazon or Google really does with their data. We have to take their word for it. In fact, if anything, we sign away half of our rights to these data because the cloud is this strange way of letting the companies decide what happens to the data that you have.
But even Professor Hu admits that the cloud is here to stay. Amazon's AWS is on track to make $16 billion this year, dwarfing the part of Amazon that most people know, the part that sells books and things. AWS is growing at 40% a year, and Loudoun County can't build data centers fast enough. Buddy Reiser says there are 7 new ones under construction right now.
And how long will it take them to build that?
Probably under 2 years.
Are you saying that this kind of construction is being built to anticipate the demand a couple years from now, or is there already enough demand to fill this?
This is 100% leased already. I mean, it's not getting ahead. We're just barely keeping up. There's no empty space in our data centers. By and large, they're all 100% filled.
Now, maybe just to go back to the video, there are several things that is mentioned that I'd like to give examples and drive the point home. One of the things that we saw in the video was that if you noted, the interviewer was talking to somebody from Amazon, which is like 16 times bigger than all the competitors combined. But at no point did you see the interviewer entering an Amazon data center. They had to go to one, what was the name? Raging Wire data center, just to show us what is there. Now, the security of the cloud is taken so seriously by the big players such as Amazon and Microsoft that they do not allow tours into their data centers. You cannot film inside at all. Even when you search on YouTube, I think there's only 1 or 2 videos for Facebook data center and an old video for a Google data center, which is basically a marketing tool for them. The other thing which was mentioned by the professor was castigating the idleness of the cloud, was that he says that the data centers are idle 96% of the time. I don't know where he got that statistic, but even if they're idle, what that shows is that the economies of scale that are available on the cloud are massive for anyone who needs computing services on the cloud. Now, let's move on to define the cloud further in terms of what the cloud proposition is. Now, there are 2 things. There is you are either on the premises, your servers are either in a room somewhere in your offices. Like I believe most organizations currently have a server room where their servers are kept and cooled. And that room mostly usually has a biometric access. And that is what we call, as is listed here on the first column, as on-premises. Now, what on-premise means is that the owner of the data center or the server room is responsible to manage everything in that server room, all the way from the networking that is there in terms of the LAN and the connection to the internet, the storage. They need to be responsible and manage the storage, the operating system licenses, the applications licenses, and all that. And if you've done or dealt with IT operations, you'd realize that licenses for software is not something cheap. And so are the servers and hardware that are needed to run a server room. What cloud proposes to the users of IT services is that they can offer various levels of cloud services. Either they can give you the infrastructure where you can run your softwares, the operating system, and the application that you run. For example, if you're running a specific software to record sales, like an ERP system, the cloud provider can give you the servers where you can host your ERP on. Yeah. So that is called infrastructure as a service. And by that, it means that when you go to the cloud and get infrastructure as a service, you can be able to lease a server on the cloud, install the operating system. The color coding here in blue means you manage, that is the customer, and orange means others manage, that is the data center or the cloud provider, basically. So in infrastructure as a service, the data center provider will provide networking, storage, servers, and virtualization, and a virtualization environment. And then the customer provides the operating system. So they'll give you a server where you will install maybe Windows Server or Linux, whatever you want to run. And then on top of the operating system, you will then run your middleware, like VMware. and your runtime environment and your data and applications. So in this type of offering, the customer is responsible for more of what happens on the cloud, because all they're given is an infrastructure. It's like they're given a server on the cloud. This is a server, install whatever you want on it. The second phase is what is known as a platform as a service. So the first one is called IaaS or IaaS, or infrastructure as a service. The second one is platform as a service. What is the difference? In this offering, the data center or the cloud provider will provide you everything, including the operating system licenses, the middleware, and the runtime. And all you do is input your data into the system, and you run your applications. What is an example of that? You might want to have your database, for example, running on the cloud. You might have your server here in Nairobi, but because your database is very large, for example, if you look at I'm not saying that I'm privy to it, but if you look at the M-Pesa database, for example, it's a very large database that is written and read thousands of times every second as users do transactions. So if you are a small player and you cannot afford to provide the computing or the storage resources for that database to run efficiently, then you can decide to run that database on the cloud while all your other services run elsewhere, either in your premises or something. So that gives you the ability to run services on the cloud that are going to require only you to manage the data that is in the cloud, and not managing the operating system or the licensing of the operating system. And then you can put your applications on top. For example, in the case I've given, you can have your database run on the cloud, and then you can have the various M-Pesa APIs or applications also run on top of that can query and read the data very fast. The third offering is usually known as software as a service. And in this offering, the cloud provider provides everything from the networking all the way to the applications. A good example of this is the Microsoft Office 365 offering, where all you need to do is use the software. When you're using Microsoft Office 365 on the cloud, you're not interested on whether that Office 365 is running on what type of server or where it's running from, or any other thing below that. All you're interested in is logging into your Office 365 and maybe sending emails or composing documents and saving them on the cloud. So that is infrastructure as a service. Sorry, software as a service. Now, there are usually different offerings on the cloud services, because different organizations have different needs at different phases of their cloud adoption journeys. And let me give you an example. Let's say beginning of this year, an organization renewed its licenses for their Windows operating systems and all the laptops in that organization, and all the servers that run in that organization. And they spent, let's say, about 5 million shillings to renew those licenses for the year. But then in March, due to COVID and all that, most of their people are now working from home. And this therefore means that majority of these users are no longer connecting to these services, to these servers from the office network, which of course is very fast. Majority of your users are now connecting to these servers from the internet. And based on that, maybe your internet capacity is not sufficient, or maybe because now everyone is working remotely, your computing resource requirements have drastically risen. And now you want to move to the cloud, but you had already spent 5 million, Bob, on renewing your licenses. So what is the option there? you can go for infrastructure as a service, where you migrate to the cloud and you migrate with your licenses. So that cuts down the cost of migrating to the cloud. And as you realize, moving from infrastructure as a service, platform as a service, software as a service, infrastructure as a service ends up being much cheaper per user, per use, as you move towards software as a service. So this organization that has these licenses now in their hand, and now they want to move to the cloud, they go sit with their CEO and their finance guys and say, we want to move to the cloud because of the new normal, what people are calling the new normal. But then the finance guy is like, you can't move to the cloud. We just spent 5 million shillings the other day on renewing licenses. So what are we going to do? So with infrastructure as a service, you're able to migrate your existing setup in your office directly to the cloud. Basically, you lift and dump into the cloud. Exactly what you have in the office, you take it to the cloud. So that is a good proposition to such organizations. In platform as a service, the organization might decide, yes, we spend this amount of money, but because now maybe our business has grown dramatically due to working from home and us being able now to recruit more sales agents or something, our database is growing very fast in terms of what we are doing. So in as much as we spend this money on these licenses for these servers here, the IT manager might propose that the non-critical services or the services that need more computing power, like the database only, to be moved to the cloud. So instead of moving the entire application and the entire IT system to the cloud, you might decide to only move the database to the cloud. And that also is an attractive offering to some organizations, yeah, and maybe some applications also to the cloud. Then there is the software as a service offering, which essentially provides everything. All you need to do is log in and start using the service. Examples of software as a service I've given is Microsoft Office 365, where you can do Microsoft Word, Outlook, Excel on the cloud and save everything on the cloud. Another example would be an online shared ERP system. Like if you are a very small business, you can go to Safaricom and tell them, I cannot afford an ERP system or an accounting system software. And then Safaricom can give you an instance on a very large ERP system that they lease out to various small businesses. So instead of spending, let's say, $10,000 buying a license for an ERP system, you can go to a cloud provider and say, I need an ERP or an accounting system for my small business, and I'll be paying on a per-use basis. So that is also an attractive offering to small organizations who would otherwise not have afforded large upfront costs in purchasing or installing these systems. And another example of software as a service is the example that we saw in the video, where this guy was saving his pictures on the cloud, on the iCloud, which is a synchronizing or backup service for Apple devices. That is an example of a software as a service, where you get a service online by accessing that software directly, and you're not concerned about what is powering that software. All you need is to log in and do whatever you need to do. So those are the major cloud propositions, and it does not mean that they are siloed the way they are. You can have organizations combining a mix of all these. You might have an organization that has on-premise services mixed with a little bit of infrastructure as a service, and maybe mixed with the software as a service. A good example, most organizations today have mixed on-premise and software as a service. In what way? Companies that already have investments in on-premise systems will still find it advantageous to move systems like Microsoft Office to the cloud. So everything else that the company uses in terms of their internal operations and databases is available on their on-prem, but users who are using Office are using it on the cloud. So that's an example of how these can be combined. And the combination is really dependent on what that business's needs are. So migrating to the cloud is not just a matter of copy pasting what you have on your premise and dumping it on the cloud. In fact, if you do that, most of the time you end up incurring more costs if you don't do it carefully than running the services on premises. These combinations can also be used as a cloud migration journey where from on-prem, a user might decide for the next 2 years, I will be on infrastructure as a service, maybe for one reason or the other. For example, if the licenses that we had just bought expire after 2 years, we might decide to be on the cloud using infrastructure as a service for those 2 years until the license expires. And when the license is about to expire, we'll now start setting up platform as a service, where now we say, instead of buying licenses for all these things, let us get the platform online and be able to host our system on the cloud without the need to worry about operating system licensing and management and patching. One thing I need to mention is that when we say that the data center is responsible for a particular aspect of the cloud service, by responsibility we mean, for example, if it's a Windows operating system that is running on the server, the cloud provider is responsible for making sure that it is up to date. So if you're on Windows 2016 and there's a new Windows 2019 that comes up, in a situation where you're using platform as a service, the cloud provider will upgrade from 2016 to 2019 for you without any additional costs on your part. However, if you're on infrastructure as a service and you are on Windows 2016, all the patching and updates and upgrades, that is your responsibility. Now, if you're an organization selling ice cream, you do not need to hire an IT guy to be doing all this work and or even expend your resources towards managing the operating systems and licenses. So you'd rather move to the cloud and save on that aspect, because what the cloud is trying to provide is the ability for organizations to focus on their core activities. So if it's a restaurant, they do not need to have an IT department to run their IT. They should focus their energies on high value activities such as running the restaurant or running the hotel or whatever they're doing. Yeah. So when an organization now moves from platform as a service to software as a service, there are various instances that they can use, and we'll talk about serverless architectures. And of course, the migration from on-prem to software as a service needs a lot of planning, needs a lot of design, needs a lot of monitoring and fine-tuning. And the aim of doing all that is to ensure that you derive the cost benefits of moving to the cloud. One thing people usually have a misconception about is thinking that by just moving to the cloud, you save money. That is far from the truth. We've had organizations that have ended up spending more by moving to the cloud compared to when they were on their premises. So it is something that needs to be planned carefully and executed well. Yes, Mohammed.
Thanks, Tom. In fact, there's a question I was about to ask. The savings from on-premises towards software as a service.
Sorry?
The savings that people make, that
Yes.
entities make as you move from on-premises to pure cloud.
Yes. In terms of the quantifying the savings.
Yes, because if you don't have such an, you've just said it's not always true that you save.
Yes. So if
What
you
is the case? How do you make a case for? Because we are here for one reason is to help CA maybe with using cloud more.
Yes.
One is cost issue vis-a-vis what we are doing now. The other is security and the privacy and that assurance, the fear. If you said yesterday the US Department of Defense is on cloud, I think there is that gap to be filled. One is these days in Kenya is finance resource. If you are not spending less, no one goes here. If it's not secure, no one goes here. That assurance about some savings and, as you say, there's planning and analysis and decisions to be made.
Yes.
We have the gaps. I think there's a lot of gap to make such plans, analysis, very informed IT, advanced expert analysis. To say no, it's better we spend the same or slightly more to go pure SAS or stay or mix. Thank you.
Yes, and that is why you need to involve experts, basically cloud architects. The aim of a cloud architect is to architect your systems in such a way that the move to the cloud actually gives you both operational and cost benefits as you move to the cloud, because you can go to the cloud and gain immense operational benefits, but zero cost benefits. So it's important to ensure that when you engage, when you start the process of moving to the cloud, you engage a qualified cloud architect who will be able to design your systems in such a way that when you move to the cloud, you derive those benefits. For an organization that goes to the cloud and ends up spending more than what they did when they were on premise for the same services that they were running, or for the same request for resources, that is a sign of poor architecture. So it's always very good to involve organizations such as mine to help you organize and plan and architect your way to the cloud to ensure that you derive those two benefits. And as you've mentioned, there are so many concerns, and everyone is looking at the financial side of things. The proposition to go to the cloud to some organizations would be in terms of the operational benefits as compared to the cost benefits. To some organizations, they would be looking more at the cost benefits. And let's use a good example. When the Kenya National Exam Council releases results, what usually happens? What used to happen? Immediately the minister announces the results, the systems go down until maybe around 8 p.m. because they are unable to cope with the amount of traffic of people sending SMSs. I send an SMS, I don't get a response, I send another one, I use my Safaricom line to send another message. So at the end of the day, the entire country is busy trying to connect to these servers and they crash. That is an example of on-premise. That is what on-premise does to you. So to the exam council, they would need to move to the cloud in such a way that on all days of the year, they are using only the capacity that they would normally use for their normal operations. But on that day that the exams are announced, they would need maybe 20 times the capacity that they normally have on their systems. So they have two options. Either design their on-premise system in such a way that it is over-designed to cater for only 2 days of the year, 7 times the capacity running just to cater for 2 days of the year, or they can design their system in such a way that they move to the cloud and use only what they need, but on those 2 days of the year, they can scale up massively and meet all the demand that is available for that day. Another example would be maybe a florist. A florist who is online would be busy maybe around Valentine's, or maybe mostly around Valentine's when the business is booming. So this florist does not need to have 10 servers waiting only for Valentine's Day. Yet maybe on ordinary days, they need only one server to serve their needs. So when they go to the cloud, they can lease one server and use it every day. And on the cloud, a good architect will design the system in such a way that should demand rise on around February 13th, let's say from February 10th, when people start placing orders, then another server is added maybe on the 11th. Maybe on the 12th, 4 more servers are added because you're closer to the date. On 13th, which is the busiest day when people are ordering, then they might need 10 servers to meet that demand. And then on 14th, of course, there are always some latecomers. There'll be some orders. On 14th, you do not need to have those 10 servers running. You might scale down to 3 to cater maybe for the latecomers, maybe those who forgot that they have girlfriends and wives. But later, on 15th, you go back to 1 server. So that is the beauty of what the cloud provides to businesses, in that they're able to scale up and down depending on their needs. Now, you can have somebody design a system like that, but still end up paying more. How? Because a good architect will say these systems should scale when there is demand, but they do not put controls around it. For example, if I'm a florist, it would be very odd if all of a sudden, instead of the system using 1 server, there are 20 servers in use on, let's say in April. Yet my peak demand is from 10th to 15th of February. So a good architect would put in place measures to ensure that maybe only during the periods that we know there's going to be high demand, that is when the extra capacity will be available. In instances where we are very certain that we will not have that demand, the system can be designed in such a way that it does not just scale up anyhowly. Yeah. So you might put controls and say, yes, we can scale up to 50 servers, but we can only scale between 10th of February and 15th of February. That's it. Or any other day that we think we might have demand, like maybe on a certain public holiday where people order more flowers, then you might scale further on that bit. So the design is very important to ensure that when you design for the cloud, it is designed in such a way that it does not cause extra expenses. Now you might be wondering, how would the demand rise yet customers are not ordering flowers from this florist? It could be maybe a system has been hacked, or maybe your application software is misbehaving and consuming more resources. Remember, you pay as you use. So if you have a database that is replicating its contents out of control, or maybe there's a bug in the system that is making your database grow very fast, that would be an alarm. To a well-designed system will send an alarm and say, we are noting your database growing very fast at a time when it's not supposed to be growing this fast. Then you can be able to take control and stop that. I believe I've answered your question on that bit of the cost element and the benefits that people derive. It is all dependent on how well the system is designed by a competent architect. The truth or the reality is, the philosophy of operating an on-prem service, IT service, is totally different from the philosophy of operating a cloud service. Those two are totally different. So most organizations are making mistakes by using their internal IT resources and say, hey, we want to move to the cloud in the next 6 months, without involving professional cloud designers. And what happens is that they end up copying that philosophy of on-premise management to the cloud, and that ends up costing them more. Now, as I've mentioned, we have several combinations of cloud. There is what is known as the public cloud, the hybrid cloud, and the private cloud. The private cloud is where the cloud service is dedicated to a single organization and is available only to that organization. And that organization has great flexibility in controlling what runs there and how systems are managed. A good example of what we would call a private cloud is, for example, all the systems that run maybe at, let's say at Safaricom. Let me use that as a local case. In their data center, they run a private cloud where all those systems, M-Pesa and all those transactions and everything that they do on IT resources is hosted there. However, using Safaricom again, they might decide that our databases are too large. We need to move the databases to the public cloud. So by them running some of the systems in their premises and the database in the cloud, then they come to the next phase, which is known as the hybrid cloud, where it's a mixture of what is on your premises and a mixture of something on the cloud. Yeah, this is usually good. It's usually a first step towards migrating fully to the cloud. Now you need to differentiate between on-prem servers and the private cloud. On-prem servers could run independently. You might have a server that is running the accounting system. You might have another server running the HR system. Another server might be running the customer support ticketing system. That is a on-prem server room. In a private cloud, all these 3 or 10 servers that are in that premise are all combined into one. So they work like one big giant server. And that process is called virtualization. So what you do is that you'd have a rack, maybe with the 10 servers on it, and you do not split those servers into running different applications or different resources. You combine them using a virtualization environment. A good example of a virtualization system is a VMware. So you'd have all the servers have VMware installed, and all those servers would act like one big monolithic server. And in that one big monolithic server, you can now create virtual servers in it. So let me stop sharing and use the whiteboard. So that I give an example. I can't see that, but anyway, let's share. I'll draw it later. So let me use this to demo. So in an on-prem setup where you do not have a private cloud, each server functions separately, where you might have this server doing one aspect of the business, then server number 2 doing something else, server number 3 doing something else. Now, what that means is that if server number 1 is idle, maybe it's a weekend and the customer service team is not working, So that server might be idle. Yet it's a weekend on a month end, and the finance team is in the office trying to close the books of account. So their server number 2 usage goes very high because they are busy. That limits them only to server number 2. Yet server number 1 is idle and unusable to them. So in a virtualization environment, what you do is that you put all these servers in one big monolithic server, which is a virtual server. And then inside, you create instances of each service that you want to run. And these instances can grow and occupy or use the additional or the idle capacity in other servers. So in this case that we've used here, where we have the finance team server maybe being overutilized due to what they're doing, in an instance where it's a virtualized environment, the idle capacity in server 1 would be made available to the service that was actually running in server 2 in this virtualized environment. So in such an instance, in the example we've given, if this is server number 2 here, and they are busy, they would expand to utilize the resources that had been allocated to server number 1. And the same thing for server number 3. If it needs resources, it can expand to utilize maybe on that Monday morning, because the finance team was busy the whole weekend, none of them are in the office. And the customer service team all of a sudden is overwhelmed by the ticketing of faults or something, or new customer orders. Then this server number 3, which maybe takes customer orders, can utilize the resources that would have been allocated to server number 2. So this is what is called a private cloud, where you must virtualize your systems to enjoy the benefits of the cloud. In this instance, this is not a private cloud, where these are just servers seated in an office, and these are very inefficient way of running IT resources. Sorry. Give me a second as I... So sorry for that. So when you run a private cloud, you must have virtualization running. Otherwise, that can be considered a private cloud. So in the case of Safaricom, they might have 20 racks, each having, let's say, 20 servers. And all those servers work as one big server. So in instances where the demand for use of a service like M-Pesa shoots up, like 24th of December, yeah, when majority of their staff are at home, yet everyone is busy sending money to their relatives in their rural areas. Workers are being paid to go for Christmas, so the systems are very busy. The capacity that would have been used by the finance guys to run their bills and all that, or the capacity that would have been used by the engineering design team, can be made available to the M-Pesa service. And I'm using that as an example. I'm not saying that is what they have designed it as. I'm just giving a familiar example of what is most likely the scenario that they have. Now, the public cloud is exactly what it says. It's a cloud that is accessible to the general public. And this is what most people know as the cloud. When most people talk of the cloud, 70% of the time, they usually mean the public cloud. And this is the cloud service that is provided by providers such as Amazon, and such as Microsoft, Google, Alibaba, IBM, and many more. But the biggest players, as you saw in that video, is Amazon, which is actually, that video said 14 times. It's now 17 times larger than all the other players combined. So Amazon is 17 times larger than Microsoft, Alibaba, Google, IBM, Oracle, all those guys combined. So 17 times larger. So in the public cloud, you lease a portion of the space there. Now you can imagine the example you've given of 3 servers. If you look at Amazon with thousands and thousands and thousands of servers, all working as one large monolithic system where they can lease out instances. It means that as a business, for example, the National Exam Council, if they go to the Amazon cloud, they can expand from the 1 server that they need every day for their operations, as an example, to maybe 300 servers within a minute. That is impossible in a private cloud or in a data center that is hosted by the exam council themselves. So the public cloud gives massive scalability to organizations that require massive compute power on short notice or for brief periods of time, depending on their traffic patterns. And these services are usually on a pay-as-you-go model, where you only pay for what you consume. So the exam council might say, we will need between 1 and 50 servers. But if they're using 1 server, they will pay for 1 server. If tomorrow they are setting the exams and they need 2 servers, then they will consume and pay for 2 servers. And even those 2 servers, if they're only being used from 8 a.m. to 5 p.m., then they only pay for that period of time that they've used them. When they come back tomorrow again, they will start paying again from the time they start using them. So that is what is called as pay-as-you-go model. And that makes the cost much less. We'll see an example later how much less that costing is. Now, of course, there are advantages and disadvantages of each and every one of them. The biggest concern on public cloud has been security. And there's always a concern that there is lesser security, which is true, of course, because if for example, I am hosting my services in a public cloud, then I have no control of the security. And by lesser security, I do not mean that there is not enough security. It might mean it is not up to your standard or up to your legal requirements, yeah? Because some organizations have legal requirements in terms of the security of their data, like banks, insurance organizations, medical or hospitals, and all that, because of the sensitivity of the data. Yeah. And the other concern is there's less flexibility and control on the cloud, but we'll see that that is slowly not becoming the case. So those are the 3 models of cloud: hybrid, private, and public. So in hybrid cloud, you might have a hybrid cloud where you have on-premise servers connecting to a public cloud, or an on-premise cloud configuration connecting to a public cloud. So there is a difference. Now, some of the major cloud vendors, as I mentioned initially, is Microsoft, and their cloud service is called Microsoft Azure Cloud. And they also offer another service called Microsoft Azure Stack. And the differences between the two is the Stack is actually a form of private cloud. So there is Microsoft Azure Cloud, which is the public cloud, and there is the Microsoft Azure Stack, which is a form of private cloud. Now, when you hear an organization like a bank moving to the cloud, it is not entirely necessary that they are on the public cloud. They could be on a private cloud. Now, what is the difference? Why should they have a private cloud for themselves? There could be legal requirements. For example, in the banking industry, there is a requirement that the customer data should not be processed outside the country. It should not leave the country. Yet this organization wants to move to the cloud. So Microsoft can set up an Azure stack to provide a private cloud configuration for you. And this stack does not necessarily have to be in the building where the company operates. For example, going back to exam council, if they decided we want to go because of the sensitivity of our exam data, and maybe, I don't know, but maybe there's a requirement that their data shouldn't leave the country, then for them to move to the cloud, they would need to, for example, get Microsoft Azure Stack. But now, the concern that they might have is their offices might not have the requisite power, the air conditioning, and the security that is necessary. So they might decide we will buy Microsoft Azure Stack, but host it in a data center in Nairobi, maybe like the East Africa, the Africa data center, or maybe the Icolo data center, or maybe the Safaricom data center. So they can go to Safaricom and say, we want cloud services, but we are going to get Microsoft Azure Stack and we want to host it in your data center. So then they can host a private cloud. And this stack works very similarly to the public cloud. If you are familiar in configuration and management and administration of the public cloud, then the stack is the same, only that it is a private cloud. Then we have Amazon Web Services, which is called AWS, which was the pioneer in cloud services in 2006. That is a very long time in internet time, 2006, that's when they started. And Microsoft started it off as by chance, because when they were running their Amazon.com services, they realized that they were using a lot of computing power, and their internal IT team became so good in setting up additional compute capacity to the point that they thought, if we could only lease out this extra space that we have, then a new business was born. Where now, other than just those data centers serving their internal needs, they were able to scale out those services and lease them to the public. And as we mentioned, Amazon is very large, but Amazon is large and popular when it comes to infrastructure and platform as a service. That's why they are popular and large. Microsoft is very strong on software as a service. The Windows, the Office, the CRM system that they provide, Microsoft BI, Business Analytics, and all those other services. So in as much as Amazon Web Services is larger in terms of capacity, compute capacity and resources that are available, it doesn't mean that they're the strongest in each and every sector of the cloud offerings. Microsoft is very strong on software as a service. That does not mean that they don't offer infrastructure as a service and platform as a service. They do, but their strength lies in software as a service, because they were initially a software company, remember, and they have been very successful. In fact, were it not for Microsoft embracing software as a service, I strongly believe Microsoft would have been dead by now. It had nearly died when Bill Gates left and his sidekick took over. They nearly closed shop. But when the likes of Satya Nadella came in, we saw a lot of change. And Microsoft is billed as one of the biggest comeback stories on the internet ecosystem. Then, of course, there's Google Cloud. Google Cloud basically offers services similar to the two above. It's not really picked up with many, but there are strong indications that they will soon be able to comfortably compete with the first two. And this is because Google is investing a lot on serverless architectures, which we'll discuss later. And they're also investing a lot in artificial intelligence. I would want to believe that Google is the largest player and researcher in artificial intelligence. And because, as I mentioned yesterday, artificial intelligence is the next big thing, Google stands a very good chance. And the reason why also they're not very big is because they came very late to the party. Yeah. So when they started offering Google Cloud services, Amazon was already very well established. Microsoft was already very well established. And that posed a challenge because Google now did not have customers to woo, because all the big guys had already been hosted in Amazon and Microsoft. So what Google did is that they created a system that is known as containerization. What containerization means, and we'll discuss it later, but let me just mention, is that instead of maybe having your, let's use back again to the exam council. Instead of the exam council running their database and their system that you can query by SMS, instead of installing it on a Windows server, for example, or a Linux server, they would install it in what is known as a container. And a container is basically virtualization within the operating system itself. And when something is running in a container, it does not care whether it's running on Linux, whether it's running on whatever platform it's running on, it will run, because the container is designed in such a way that it is operating system and underlying system agnostic. So Google did that to make it easier for guys who are already in Microsoft and in Amazon to migrate to them. Yeah, and I think they've succeeded. If you read about containerization and serverless architecture, that is where everyone is going. So if you run your systems on a container in Microsoft Azure, to migrate from Microsoft Azure to Google Cloud is very easy. To migrate from Amazon Web Services to Google Cloud is very easy, and vice versa, because what Google did, they opened up the containerization code and made it open source, so anyone can do it. So Google has its own containerization system, Amazon, Azure, all of them have. And one of the things that last year but one was a hot topic is that for Microsoft to survive in the next 5 to 10 years as a cloud, as a big cloud player, they need to adapt Microsoft's Azure for containerization, because everyone now is running their systems on containers. And the reason they're doing that is because they do not want to be tied to one cloud provider. Today, if I'm running my containerized service in an Amazon Web Service cloud, let's say of their region in Europe, and tomorrow Google announces we have a data center in Nairobi, and we are offering these services, it will be to my advantage to move from the cloud provider in Europe to Nairobi. But then that would involve a lot of processes and a lot of tweaking of the software and the system, and that will cost a lot of time and money. And it might not be an incentive for me to do that. So by releasing containers, Google simply lowered the barrier to entry onto their cloud service. Because now when you think about it, if I have all my services running in a container, all I need to do is pick up the container and take it to the Google Cloud and it will run. So Google's strategy of making sure that it wins in the cloud is to front containerization and serverless architectures. and it seems to be bearing fruits. Other providers are Alibaba, which is a very big Chinese player. In terms of computing capacity and data centers, they're very strong in China and Asia. And in the US, where they're also trying to get, and in Europe, that service is called Ali Cloud. I don't know why. Maybe Alibaba Cloud is a mouthful to many people, but it's called Ali Cloud. There are also other cloud vendors, such as VMware, Citrix, Oracle, Red Hat. And as you've seen, they have started them because these other vendors mostly focus on private cloud virtualization, that they can offer private cloud for you. So today, if you need to run a private cloud, you have the option of going to Microsoft Azure Stack, or you can use VMware or Citrix or Oracle or Red Hat to create a private cloud in your premises. So that is the major difference between these players. And the other thing you need to realize that even when you go to Amazon, or maybe you go to Amazon and Microsoft and look at how they are doing virtualization, they are using one version of these 4 last virtualization environments. Now, when you talk of cloud services, what do we mean exactly? We mean that there is a compute, that you are leasing compute capacity. The CPU or GPU that we all know of, you are leasing RAM or memory, volatile memory. You are leasing an operating system. And I've studied because it depends whether it's infrastructure as a service or cloud as a service, or so on and so forth. So if you're leasing infrastructure as a service, you most likely will be leasing compute services. If you are leasing mostly platform as a service, you'll most likely be leasing storage and all that. If you're using applications as a service, then you'll most likely be leasing application services. But all these can be combined. I can lease compute, maybe set up a server on the cloud, and then also lease storage on it, and then maybe decide, let me also lease a database from these guys, because maybe I want to transfer my old database to a newer database when I move to the cloud. So this is what people pay for on the cloud. Now, when you're paying for anything on the cloud, it is because you've consumed any of these resources. Either the application ran, or you consumed storage, or you consumed compute. Any other service is offered for free. For example, if you go to the cloud, you need to set up firewalls for your systems. You need to set up rules on who can log in and who can't log in to the system. You need to set up access lists, maybe which network can connect to it. Because if I have a server in the cloud and I am the administrator of that server, I would not want anyone from the internet to connect to it. So I might create a rule, an access list that says that people can only connect to this server if they are originating from a particular IP or from a particular network, maybe in the office. So if that server is at the cloud and you want to modify it, you must be originating from a particular IP address or from a particular network. So in this case, if it's a network, then I need to make some changes on that server. I must rush to the office and make that change because I have to be in that network. If I'm in the house, I can set a rule that says, allow this IP, because this is maybe the IP that maybe Zuku or Safaricom or Hai gave me, and say this is your IP address. So I can allow that IP address to connect to the cloud from my house. But I do not want any person on the internet to connect. So those services are usually offered for free as a confidence booster to organizations that indeed the cloud will offer the level of security that they require. I'd like us to take a brief break for how many minutes? 5?
Okay.
Yeah, we can take a 5-minute break and then convene again. So we can pause a bit. So can we continue?
Yes.
Okay, thank you. So now, as I've mentioned, there are many cloud products that are offered by the various providers, but I'll show just an example of a screen grab of what these providers have. And this is an example of Microsoft Azure, where on compute side, they offer virtual machines and what are known as virtual machine scale set. What that means, in a virtual machine, you can get one, for example, like if you want one server. And virtual machine scale set, it means you can get one that can grow. Like if the demand is there for a second server, then it comes in. And you have the flexibility of choosing when that second server comes in. Maybe if the CPU reaches 70%, then a second server must come in to help. Or if the amount of data being written to the database exceeds this much, then another server comes in to help. So National Exam Council would be a good candidate customer for virtual machine scale sets in the example that I've shared. That they can get one server or two, and then when they release the results, they might scale up to 100 or whatever number they choose. Then of course, there are other things like application service, functions. Functions are an example of serverless architecture, which we'll cover later. Container service, Microsoft grew wise and started offering containerization and container instances, and many other services which we won't really discuss. But on the networking bit, which is down there, they offer what is known as a virtual network, where you can, the same way you have a virtual network in your office, the same way you have a physical network in your office that connects all the systems in your server room, you can create a virtual network on the cloud, which does exactly the same thing, if not better. Then a load balancer. A load balancer is usually good in instances where you are running several server instances, and you want to balance the load that is coming in across two servers in a way using an algorithm or technique that suits you. Yeah. Then there are other services: VPN gateway, DNS, application gateway, content delivery network. What is a content delivery network? Let's say, for example, let's use an example of Netflix. How would Netflix use a content delivery network? A content delivery network is a system where the content that is being served to customers is delivered to the closest point of their consumption. So if today I watch a Netflix movie and then it's all of a sudden it's popular in Kenya, everyone is watching it, or maybe I watch a funny video that is being shared around and everyone is busy watching that YouTube video or something, then instead of that video being hosted in the Google data center somewhere in the US or in Europe, a copy of that video only can be stored here in Kenya locally. And that copy of video, anyone else who accesses it from the Kenya network, maybe Safaricom, Airtel, Zuku, wherever, they will fetch that video from Kenya in Nairobi. They don't have to go all the way to Europe. And content delivery has really helped, because if you've noticed, rarely do videos buffer these days, because most of that content is here in Nairobi. It's not out there in the internet. And many other services, which we won't have time to discuss, but we can explore. One of the services maybe I should mention is this one called ExpressRoute under networking, the second last. What ExpressRoute does is that an organization decides to move to the cloud, like yourselves, and everything is in the cloud. But now you are worried that we are using an ISP here in Kenya, and we don't know what they do with our traffic. So we can't guarantee security of our traffic in transit. So instead of getting an internet link, you get what is known as an express route. And an express route is simply a fiber cable that runs from your premises all the way to where that data center is. And that fiber cable is not in use by anyone and is not interrupted by any provider along the way, all the way. So if you go to an organization, let's say, in this case, let's say Liquid Telecom or Safaricom, they can give you an express route from your premises all the way to, let's say you're hosting your services in a cloud instance in South Africa, all the way to South Africa. So that guarantees you security of your data in transit and when accessing that cloud service. Because remember, if, for example, a bank decides to move all their services to the cloud, they wouldn't want to pass their ATM traffic over the internet. They wouldn't want to pass their transaction traffic over the internet. They would want to pass it via a more secure route. A VPN would work, but a VPN is just that. It's a virtual private network. As in, it's a private network that exists on a public network. That's why it's called virtual. An express route is a true private network. Yeah, and it's offered as a service. And many other things. And if you look at these products offered by Microsoft and by Amazon, they are very similar. Yeah, on the Amazon side, for example, if you look at networking, what Microsoft calls Azure DNS, here they call it Amazon Route 53. Why Route 53? 53 is the port that is used by DNS, so it's just a fancy name. If you Google Route 66, you'll know what drove them to use that name. Then Amazon VPC is, Amazon Direct Connect is what Microsoft calls Express Route. Yeah. So most of these services are similar in terms of what they offer, and it's up to the user to decide what suits them. Yeah. So you cannot use a Microsoft Express route to go to Amazon. It only goes to a Microsoft data center. So one of the biggest advantages of cloud is that it offers high availability, fault tolerance, scalability, and elasticity. So many English words, but let's see what they mean. Now, when you talk of high availability, you most often refer to fault tolerance. Most people tend to use the terms interchangeably. That high availability and fault tolerance are the same. They are not. A fault tolerant environment is where there's no service interruption, but there's a significantly higher cost to ensure that there's no service interruption. A good example of a fault tolerant environment would be the M-Pesa service. They would not suffer service interruption. And if they did, they would even be penalized by the regulator in some instances, like as happened before. So an organization like that will have to pay more to ensure that their systems are designed in a fault tolerant way. And this is where cloud architects and cloud design companies have to come in and design a system that is truly fault tolerant, not just high availability. While on the other hand, a high availability system or environment has minimal service interruption, but it will still run. A good example is the high availability service for let's say, what example can I use here that is good? Let's say a betting website. A betting website might be very slow over the weekends, but that's still fine. You'll still be able to place your bet, though it might take slightly longer because maybe their systems are overloaded and maybe some of the traffic maybe is now being routed to other servers that are a bit far away. But a fault-tolerant environment for a betting company would mean that you would not notice the difference. It will still work. So that's the difference. So you spend more money to ensure fault tolerance than to ensure high availability. Yeah, and in most instances, you find that the design of the fault tolerance is usually at the application level. And another example of fault tolerance is you have an interface where you're accessing maybe the exam results, but for some reason or the other, that database where it's hosted crashes. In a high available environment, there should have been designed in such a way that there was a backup of that database seated somewhere else separate that this system can now connect to. Yeah. So the fault tolerance design is often a customer's responsibility, while high availability is often the cloud provider's responsibility, as we will see. Now, when we talk about the cloud, what we saw that there are some data centers seated somewhere, and we saw some data centers in Virginia. If you look at the map there, you see Virginia is very busy there. That place where we were being told, like every other land is being used to build a data center. It's around there in Virginia. And there are many other places where Microsoft offers availability zones. And I think you see the reason why Africa is often called a dark continent. In fact, the 2 dots down there in South Africa were not there in the last year. Early last year, they were not, 2018, they were not there. So what this shows you is that the Microsoft Azure cloud is hosted in all these locations. Yeah. And these are known as regions. So for example, in Africa, there's South Africa North, which is in Johannesburg. And then there's South Africa West, which is in Cape Town. So South Africa North and South Africa West are termed as 2 separate regions. Yeah. But within South Africa North itself, there are what are known as availability zones. Remember I said availability, high availability is the responsibility of the cloud provider. Within South Africa North, in Johannesburg itself, Microsoft does not have 1 data center. They have like 3 data centers, a minimum of 2. So if you are hosting your services in South Africa North, in Johannesburg, and you configure them in a high availability mode, then a copy of your services will run in data center 1, and a copy of your services will also run on data center 2 or even 3, depending on the number. So that is how they ensure high availability. You also have the option of running a copy of your services in South Africa North and a copy of your service in South Africa West again. But that again will be slightly more expensive, but it's doable. Or even in South Africa and in Europe, or in the US or in Asia. Now, what this means is that when you are choosing a cloud service, for example, if you as an organization, as CA, you're choosing a cloud service, you choose the one that is closest to you in terms of latencies, which would be South Africa in this case. So if you're using Microsoft services, for example, Microsoft Office 365 on your laptop, it is most likely coming from South Africa. There are organizations that have systems where, like for example, if you take a large NGO that operates out of Europe, let's say Oxfam. Oxfam might be headquartered in the UK, and they might buy cloud services in UK, in one of the UK regions, but they have offices across the world. So in as much as they might buy services in UK, for their operations in West Coast of the United States, they might opt to have an instance of their cloud service also available in West Coast. And for the operations in Africa, they might have an instance running in South Africa North. So users who are in Africa connect to South Africa. Users who are in Asia connect to Asia and all that. So these are the regions. So Microsoft has 60 regions worldwide, and they are continuing to add more. And they are available in 140 countries. For Amazon, a similar design. They are available in 245 countries and 24 regions. The same setup. If you come to Africa, in Cape Town, they have several data centers within Cape Town that offer different availability zones in that region, and so on and so forth. Now, when you talk of availability zones, regions, and data centers in a graphical format, we might have an Microsoft Azure region or an AWS region. The setup is the same, as you'll see. And within this region, let's say the entire of this rectangle is Johannesburg, Africa North. Maybe on one side of Johannesburg, there is a data center where they have zone 1. And on the other side of Johannesburg, another data center, and so on and so forth. In the case of Nairobi, for example, if Microsoft came here to set up an Azure region, they would most likely have one zone at the Africa data center, which is somewhere on Mombasa Road. They would have another zone in Thika at the Safaricom data center, which is a distance away. And then they might have another zone maybe at the Ikolo data center in Karen. So in the hypothetical Kenya region or Nairobi region, there will be 3 zones within Nairobi. And if a customer buys service with high availability, there'll be a copy of that cloud service in at least 2 of those zones, or even 3, depending on your fault tolerance. In this case, I wouldn't choose the region that is in Mombasa Road and the region that is in Karen, because they're too close. I would choose the one that is in Mombasa Road or Karen and combine it with the one that is in Thika, because at least there's a distance. If there's a calamity in Nairobi or a major power issue in Nairobi, then of course you'll see what happens. So the same for, and the advantage of having these regions, they're designed in such a way that they have independent power, water, and cooling. And this is very critical, especially when it comes to power in Kenya. For example, if you look at the Africa data center, they have their own mini substation there that does not serve any other customer. That comes straight from the Kenya Power substation that serves that region. I think it's in Embakasi. So straight from Embakasi to that data center, no other customer in between. And the reason for that is because if there are many customers along the way, then there are instances where it will be shut down for maintenance, then there'll be faults and all that. And then, of course, the power won't be guaranteed. So independent power, independent water, and independent cooling. Same design for Amazon. There is no difference. They have them, they call them availability zones. So you might have a region maybe in Mombasa, another region in Nairobi with several data centers.
Just a query.
Yes.
What is the need for water?
Water in a data center.
Yes.
Water is used mostly for cooling. I can look for some videos in some data centers. Actually, it is very expensive for very large data centers to use the conventional air conditioning systems that we have. Some data centers use techniques that involve the use of water for cooling. And by this I mean the systems that run to cool the data centers are like radiators. The same way you have a car cooling system with a radiator and water circulating. The entire data center is like one large car engine with a radiator outside, which is cooling, which is being cooled by air or even being cooled by water pouring down the radiator fins to cool it by normal heat exchanged into the environment. So that is why large data centers need a lot of water for cooling. We do not have that scale of data centers in Kenya or Africa yet, where they use such amounts of data center, such amounts of water. Now, maybe just on that question, maybe I could also mention. Yes.
To say you are cooling and then you have water. So I was assuming if water is for cooling, then today the intervention is just cooling.
No, the reason why it has to be independent is because okay, maybe there's confusion there. What that means is the water source has to be independent. If there are 2 data centers in Nairobi, one in Karen, one on Mombasa Road, the water source that the current data center is using should not be the same water source that the one on Mombasa Road is using. That's what it means. It doesn't mean that the cooling and water are repetitive. Water is very critical. Now, on the same note, due to cooling, which consumes close to 30% of the power in a data center, many of these data centers are now being set in very cold countries, like Greenland, which is under Denmark. Is it? Yeah, it's under Denmark. Greenland or Iceland are very cold countries. Even when you look at Greenland on the map, it's just ice, white, all of it. Setting up a data center in Greenland, you do not need to cool it because the air there naturally is cold at 5 degrees. I think it's around 5 or 6 degrees cold. So a data center in Greenland is cheaper to run because you do not consume power to cool the servers and the systems, and it becomes cheaper to offer the services. So you find that many operators like Facebook have data centers in Greenland, Amazon, and many other providers have data centers that are hosted in very cool countries, in the Nordic countries where it's cooler. And that could also explain why these providers have been very late to come to the tropics. Previous, yeah. Other than just the fact that the customer base isn't very large, it is also very expensive to run data centers in the tropics because of the cooling aspect. Yeah. Any other question? So let's take an example where the exam council wants to set up a server that will offer high availability to their clients or the students. So when they decide to go to the cloud, they might decide that we are going to have our setup in such a way that we are going to use the Nairobi region, which is the outer rectangle. And then inside there, they will set up a VPC, which is a virtual private cloud, which is basically like a private network. The same way you'd go into an office and set up private network on private IPs and secure it by putting access lists, the normal way. So basically, this is the VPC represents your office network where your staff is stored and where your workers work from. Then the VPC is actually virtual because it can scale from one availability zone to another. You can create one VPC that connects to the availability zone on Mombasa Road and the availability zone in Thika. Then they can set up a web server in availability zone 1 and availability zone 2. So you have 2 servers in 2 different availability zones. And then on top of that, you put what is known as a load balancer. You remember we saw a load balancer somewhere. So you get the load balancer and distribute the traffic between these 2 servers. So if one server fails, let's say for some reason, that one of the data center is unavailable for one reason or the other, then the load balancer will be able to take all the traffic to that one data center that is available without the users noticing. And when it takes it to the data center that is available, then it will also scale up. Whereas maybe there was one server, it will scale up and maybe put 2 servers now on this one availability zone. Now, this service of offering across availability zones, cloud services across availability zones is advantageous, is one of the advantages of the cloud, because the minute I set up a server on the cloud and say I need it to be high available, the exact copy is made on the other availability zone. The same thing maybe for their database. The database maybe hosts the results. They might have one database hosted on the availability zone that is on Mombasa Road, as you can see here with the blue arrows, that both servers, in as much as one is in Nairobi and the other maybe is in Thika, they are both accessing one database in Nairobi. And then there's another database in Thika, which is a backup database that is not accessed. Now, this setup is actually more of a cost-saving setup, because when you set one database as active and the other one as a backup, you pay less. But if you set both of them as active, then you pay more. And it presents challenges, because if the two databases are supposed to be a copy of each other, you need only to write into one, so that whatever is written into one is copied to the other server as a backup. But if you have two systems writing to one database in Nairobi, the other database in Thika, then there will be inconsistencies. So it's always good to ensure that you get a designer who knows what he's doing as far as designing this service is concerned. Now, in instances where the reason why I said migrating to the cloud, it can cost you, is that you might copy whatever you have on your premises to the cloud, where you have two databases running concurrently, maybe for one reason. And when you go to the cloud, you end up paying more because of all the operations that you're doing. Because remember, on the cloud, when you host a database, you pay based on how frequently you access that database, or on how large that database is. You can choose to pay for either or mix, depending on the plan. So if you have a very large database that maybe is accessed infrequently, then you choose a plan that pays more for the size. Or, sorry, you choose a plan that pays more for the number of writes. If you choose a plan that pays for the number of reads and writes into the database, for a database that is not very well designed for that, you will actually end up paying more. For example, if you pay for the size of the database, yet your access to the database is very high, then you end up paying more. So the design has to be done very well to ensure that you pay less. And that's why I was saying that if it's not done well, you end up spending a lot of money for no reason. Or sometimes you might have WebHost 1 being like 5 servers, and WebHost 2 being like 5 servers, yet only 2 servers are in use. Just because in your premises, you had bought 5 servers to cater for high traffic periods, which maybe might be 2 weeks of the year, you end up spending more on the cloud with idle systems sitting there, depending on how you've designed them. Now, the other element, apart from availability, which I've touched on, is scalability and elasticity. Now, scalability is more of a strategic design thinking, where we say that as an organization today, we are 50 people. But in the next 5 years, based on the way business is doing, we might be 600. So we'll need compute capacity that will be able to grow with us as we move from 50 to 70 to 100 to 150 to 600. So you scale based on your need, yeah? While elasticity is more of a tactical approach, where you allocate computing resources based on necessity. So you might go to the cloud for the scalability aspect, that you can grow your IT requirements as your needs grow. You can also go to the cloud for elasticity, in that you say, these are my requirements, but should there be a need or an event where it needs me to immediately scale up and maybe get more computing power, maybe bring on 10 servers within 5 minutes, then I can be able to do that. So elasticity basically provides the resources required for the current workload that you're handling. And makes sure that you pay less for peak periods, for off-peak periods. Now, if you get a good cloud architect, they will ensure that they design the system in such a way that it is scalable and elastic. Yeah. In fact, the server service that Amazon sells, they call it elastic compute, just to stress that point. They call EC2, Elastic Compute Cloud, ECC, but instead of saying ECC, they say EC2. Yeah. Now, by cloud elasticity, this is what I mean, that if you have a static data center, you might have to buy servers maybe that can supply that capacity in RAID, but this is your demand. Yeah, it varies during the day or during the month or over the year. So there are instances where your capacity will be idle and you still have paid for that anyway. In fact, you'll have paid for it upfront. In the cloud, you need to design your systems in such a way that the growth of your demand and the fall of your demand can be met at that instance it's needed, and you can go up and down depending on your needs. If you do this second graph here, you'll end up saving costs. Now, if you get a good cloud architect, they can do this for you. If you get somebody who does not know what they're doing, they might transfer, because this first graph is the scenario in most in-premise or in-house hosted servers, where there are 20 servers seated there and they are used based on, depending on the use. Like at night, maybe the customer service ticketing system is idle because people have closed for the day. But at night is when maybe the finance system is busy trying to process invoices and send them out. So it might need that capacity, but it's not available. So this is what we mean by cloud elasticity. Now, there is the main attraction of cloud, of course, is the economics, as we've seen. And one of the things we've said is that you experience reduced overheads. You can set up a system immediately, use it, and you only buy what you want. And then also in terms of economies of scale, by the fact that we are sharing, for example, if I use infrastructure, if I use software as a service, I'll be sharing a license or the system with several other customers of that cloud product. So it's like we've formed a circle or come together and went and bought one license as the 10 small businesses and then use it on the cloud. So that is what we mean by buyer power. And then there are also location independent, in that going to the cloud does not necessarily mean you have to be tied to one location. You can go to the cloud and move around as your business moves around. A good example, for example, let's take a theoretical scenario where there's a flower farm in Naivasha that has cloud services in Nairobi, for example. And that flower farm, for one reason or the other, decides to move to Ethiopia. If they had in-house servers, that would be a lot of work. With the cloud, they can simply pull out their containers. Remember, we mentioned containers. Pull them out, go to a data center in Ethiopia, plug them in, and they are good to go. Those containers can be carried in a flash disk. It's software. You do not carry any server or any hardware around, and it's as easy as that. And of course, by that flower farm moving their services to a data center in Addis Ababa, the latency will reduce because now they no longer need to connect from Ethiopia to Kenya. They've moved with that. So that is one advantage. And then, of course, there's the pay-per-use model. And then you can vary your demand by using on-demand resources. You can scale, it's scalable, it's elastic. And then you can quickly bring on and decommission services within no time, and I'll show you how. Yes, Haji.
Thanks, Tom. No, I think I missed a brief discussion after the break. So this container thing, what is the interface between me and an organization and the cloud? How do I get from where my service is now to, is it those containers? What interface do I require? Apart from the direct link, the express thing aside, the one of cabling all through, what is the interface between me, a potential user of the cloud, and the cloud itself?
The interface in terms of the application you're using, or you accessing the cloud resources to configure and manage them?
Yeah, access. How do I get my content on the tech? How do I get it to there? Assuming I decide.
I'll show you. I'll show
okay.
you. I'll show you using an example. Next, I'll show you using an example how to do that. Now, just to mention, if, for example, you want to move data from one data center to the other, and this data center could be from cloud to cloud, or from your on-prem to cloud, there are also tools that are available that can help you do that easily. There are tools that, for example, if you want to move from Google Docs, Google Documents to Microsoft Office, there's a tool that can migrate your users from Google Docs straight to Microsoft Office without you sitting down, configuring new passwords, new usernames, and doing that for 500 users. There are tools that can do that automatically for you. There are tools that can move your on-prem email, for example. If you have an email server seated in your office and you want to move to the cloud, how do you move all those archived emails that have been stored in people's Outlooks for the last 10 years to the cloud? There are tools that can do that. So it's not a matter of drag and dropping files. You can use tools, configure those tools properly and say, this is what I want to do, and the tool will automatically do it for you. Now, you had also asked a question, Mohammed, on the cost reduction. How much do you gain by moving to the cloud? Now, it's not usually straightforward that if I decide today I'm moving to the cloud, then by next week I'm already seeing the benefits. In fact, it's usually quite the opposite, and many users who do not know this end up getting frustrated. It is important to always ensure that when you are planning to migrate to the cloud, the architect and the project manager are very realistic on what needs to be done. It's not a two-day thing. There's a bank in Kenya currently planning to move to the cloud. I won't mention the name, but their migration strategy is over a 2-year period. They're not saying that by July we should be on the cloud. No, it's a 2-year period. And they'll start slowly. They might start by saying, let us move non-critical services to the cloud first. Then they look at what is critical, what is non-critical. For example, in a banking environment, the core banking system is very critical. But maybe the customer support ticketing system is not very critical. So they might say, let us move our support system to the cloud first. Or even on that customer support system, they might say, let us just move the database of this support system to the cloud first. And then slowly, after maybe another 2 months, we move the system itself now to the cloud together with the database. Then within a period of 2 years, even their core banking system will now be on the cloud. Yeah. And this graph basically shows what happens. And the color code there is dark blue or black, depending on your screen, is on-premise costs. Then the grayish one is migration investments and cloud costs, and the efficiency gains, the light blue ones. So as you can see here, the total cost of ownership of moving to the cloud reduces by a factor, if you do it very well, of an average of 55%. 55% is an average. I have seen customers who've achieved 78% cost savings by moving to the cloud, 78%. So 55 is a good average if it's done well. Some might not be done very well. They might have no cost savings at all. Some costs might increase. Some might save maybe 10%. So it is very critical to ensure that your systems are well designed. Now, when you talk of economies of scale, an organization that runs very many servers would be better off on the cloud. This is an example of the economies of scale that are gained by running your servers cooperatively. Basically, a cloud service can be equated to an IT cooperative. Yeah, where all these companies say, by the way, instead of me running my servers on Wayaki Way, you running your servers on Thika Road, you running your servers in industrial area, why don't we come together and set up a private cloud for our own use? Then there are economies of scale. Now, the same thing blown up 10 times over, you'd have a provider like Microsoft offering these servers and saying, we have 100,000 servers here, and because there are 100,000, our cost per server is extremely low, below $500, our cost per server. Yet, that cooperative that we talked about of those three companies, if they combine their servers and their 100 servers, their cost per server is to the tune of $5,000, as seen there. Yeah. So by moving to the cloud, the total cost of ownership drastically reduces, because now whatever you used to spend on hardware enjoys the economies of scale that the cloud provides. Now, the thing that I'd mentioned earlier on is the upfront costs. Now, this is just a screenshot I got on the internet. Not that I'm a fan of Dell servers, but if you are to buy a Dell server today, you'd spend around that amount of money or less, depending on the specs of the server. Let's say even it's $1,000 or $2,000. This is the money that you need to pay upfront for this server to be delivered in your office. Then you'd also need to rack it up, which means you must have a server room. You must cable it and connect it to the network. You must protect it from attacks.
Before tax, yeah?
Yeah?
This is before tax, or they are not taxed?
This is before tax. This is just a screenshot on the internet of a server being sold somewhere in the US. So if it comes to Kenya, then it's double, or maybe, or triple. It could be double. Yeah. So this is a cost that you need to incur upfront when you buy a physical server. Yeah. Now let us, for example, decide. Let's do a lab session where we'll log into a cloud platform and set up a server, which will do the same thing as those servers we've seen there. Yeah. So let me log in just a moment. So once you see my screen, please let me know. Are you able to see my screen?
Yes.
So this, what I've done is that I've logged into Amazon Cloud Services portal. And then there's also the possibility of logging into Microsoft Azure. When I change the tabs, are you able to see the difference in the tabs? Because I shared only that tab.
Yes.
Can you see the next tab for Microsoft?
I do.
You do, eh? So this is the interface for Microsoft Azure Cloud Services. And when we are here, we can be able to deploy a server, just like the physical server that we saw there. We can be able to deploy a server there. We can also be able to deploy the same server on Amazon, exactly the same specs, even maybe the operating system and all that. So let's try do one server in Amazon. So let's see how long it will take for us to have that server. So we go to running instances, then just hold on. So I will say, now before I go there, I want you to see here, in terms of the availability zones, can you see there? I have the ability to choose whatever zone I need to set my server in. I can choose Cape Town there, yeah, and then it will change to Cape Town. So now any resource I configure here, any server I set up, if I say new server, it will be set up in Cape Town. Yeah. I can decide to choose, I had some servers running in Cape Town. I can decide to choose Singapore, Tokyo, or any other country. For the sake of this example, let's choose Tokyo for some reason. So now I am in the Tokyo zone. You see now there's nothing because I've not set up any server instance in Tokyo. But I can say launch instance, which means I need to create a new cloud server instance. Immediately I come here and say, now I choose the operating system. I can either use Amazon Linux or Windows or Red Hat, whatever operating system I want to use, they're all there. And some operating systems are optimized for services. Like you can get Amazon Linux, which is optimized for deep learning. Yeah, you can get Microsoft Windows, which is for enterprise or the standard version, and so many options available. Yeah, and you have the option of even bringing in your own operating system. If you're an organization that has its own operating systems, they exist. You can bring it in. Yeah. So let's say we choose. Let's choose a Windows. Let's choose this one. This Windows Server 2019 base. So we select that. Then from there, I can choose the type of server I want. And there's a long list here, which are classified as either general purpose, which is just a normal server, as in general purpose server. And there are different things specified in terms of the CPU there, the memory, the type of storage, the storage optimization that is available, and network performance. What do we mean storage optimization? You might want this server to have a hard disk that is running on the normal read-write processes in terms of the input and output rate. But you might also want to run a hard disk that is optimized for database writing, very many large number of database accesses. So there are all those options. But for this example, let's choose this general purpose T2 micro, which will give us 1 CPU, 1 GB memory, and we just need a local hard disk and low to moderate network performance. My needs might be different. I might have a need for a storage optimized system. For example, if my service stores a lot of files, then I might have a storage optimized system. If, for example, I process a lot of data in memory, I might have a memory optimized system. Or I might choose GPU instances. I'll mention GPUs later. They're mostly used for machine learning and AI. So if I'm running AI machine learning systems, I might choose a GPU. Yeah. Or CPU optimized. This is compute optimized. So we in this example, let's just choose one. I think for the sake of time. Then we've chosen that. Okay? Then we can immediately say review and launch, and the server will be up. But we can go a step further and configure instances and say I want 2 copies of this server. So I'll create exact 2 copies of this server in Tokyo. I might decide I need 10,000. Yeah. But it would be foolish for me to put 10,000 servers there, yet I don't need all of them at the same time. So I might decide that my base load only requires 2 servers, and then I can go to what is known as auto-scaling. In this configuration, which we won't go to because of time and the complexity, in this configuration, we can go in and add more functionality and say, we should have 2 as a base, but should need arise. In this auto-scale group, we say that if these 2 servers CPU, for example, reaches 80%, add another server. Or if memory reaches this percentage, then add another server, something like that. Then there are purchasing options. You can buy a server on the internet and then on the cloud, and then use what are known as spot instances. This is the excess capacity available when other guys have bought. So it's a bit cheaper. Yeah. So if you want, for example, to do batch processing for your large amount of data at night only, then you can use spot instances. It's cheaper for you. Yeah. Then network, you can create the network. You can create a new network. The same way we said, you can create an entire network on the cloud. You can create a new one, or in this case, we just use the default for the example. And then many other configurations. And then we can go next. And by default, this server came with a 30 GB hard disk. We can change that and say our needs actually 50 GB. Yeah. And then you can come there and say, we need a general purpose solid state disk. These are the new hard disks that do not have spinning disks in them. You know, the hard disk has an actual hard disk spinning inside. So solid state is electronic, so it's much faster. And it's good for faster access and processing. You can also, and it has a different cost. You can also choose a solid state disk that is provisioned and optimized for large input, many concurrent inputs and reads and writes. Or you can choose a standard hard disk, like the ones that are in most computers, older computers, a magnetic standard hard disk, which of course is slower and which of course is cheaper. Yeah. And the needs might vary. For example, if if all I'm doing on this server is is backing up the conversations that the company has had, or logs of a certain server that we use, I do not need high performance disk. I can use a standard magnetic disk and it'll be cheaper. So for this case, let's just choose that default one. And I can decide to add more capacity. I might decide, let me add a separate disk, which will be 100 GB, but this disk should not be attached to the computer. Yeah. Or in this case, we can only attach to the computer. So it's a EBS volume. So in this case, we have this system with 50 GB where the operating system will be. Then we'll have another 100 GB, but let's just remove it for that sake. So when you're done, you just say review and launch. What did I choose? Oh, I chose a different free tier. Okay, let me go back. Let me choose one that is available for free. Yeah, let's look for a Windows one. Yeah, let's choose this server 2016. Let's select that. So because my account is a free account for demo purposes, I chose that one. I cannot choose everything, I mean. So let's launch. Yeah. So we are now ready to launch that server. So let's say launch. Now, for security reasons, before you launch the server, there are what are known as encryption keys. What will prevent somebody out there who manages to get the admin username and password for this server from logging in? It is the encryption key. So we can create a new key pair, call it maybe CA test. Let's just call it class test, like that. It's just a name, but you need to give a unique name for whatever server you're using. So then you download the key pair. Then this file will now be saved on my laptop, and that is the file I will use to access that server. So when I do that, I say launch instance, and then it's starting to create it. Yeah, your instances are now launching. We can go there and wait for it. See, remember we said 2. So the 2 servers are being created, are being set up, and the instance step there is pending. Yeah. If we had selected 1, we would see 1 server. If we have selected 10, we would see 10 there. But again, there are advantages and disadvantages of those types of configurations. So that is how easy it is to do. The same thing can be done on Microsoft Azure. You go to virtual machines. In this case, they call them virtual machines. You say add virtual machine. I'm using that subscription. I can create, yeah, there's one I had created here. Let's use network watchers, like that. Or we can create a new one. We can call it class test. We say, okay. So we use that. A resource group is basically, for example, in an instance where the IT company decides within CA, we are going to have to measure the IT spend of each department. So finance, IT department itself, administration, operations, transport. So we can create different resource groups for these different departments, and it will be easier for us now to manage the resource group. The resource groups also provide a way for applying system-wide or group-wide rules and regulations on how those systems can be accessed. So in this case, we will call it, we need to give it a virtual machine name. We can call it class 1, call it that. And then in the regions here, the same way in Amazon, we configured it in a region. We can choose the region we want here. And there are so many. We can choose Africa, South, yeah. Then availability, you can choose, I do not need redundancy, or you need redundancy. Then you can configure that, yeah, based on the availability zone. The reason why availability zone here is blurred is because on the South African one, they're not, I think it's only 1 or 2, yeah. Or you can create your own availability configurations. Then you can decide, you see this is Microsoft, but the operating systems available are all. There's Oracle Linux, there's Debian, there's SUSE, there's Windows Server, all these. Let's choose even Windows 10. Let's choose Windows 10. Then we use, let's choose that. Doesn't suppose we're in South Africa, not. Oh, okay. So let's choose another region. Let's choose Germany West. Yeah. So immediately we have decided to set it up in Germany. Then we come here with the username. We can call that user test user, yeah. And then for the password, we can put a password. Yeah. And then we can configure inbound rules. the way I said, we might want to allow selected ports or selected IP addresses to access, but let's not do that. So we can go next and create disks, or the same way, or we can create the instance immediately. So here it's telling me that if you configure whatever you've chosen there, you'll be paying $0.28 US per hour. Yeah. So based on what I've chosen there, the operating system, the size of the disk, the memory, and everything, it costs that per hour. So I will be able to know, I'll be able to own a server right away with 30 shillings. Compared to the other example where we needed like 300,000 or 400,000 shillings to set up a similar instance. With 30 bob, I'm up and running. So let's create. So if you calculate this, 30 shillings per hour times 24 hours, assuming you run it full time, times 365 days in a year, that's 260,000. So you pay 260,000 over a period of 1 year, compared to paying upfront most of the cost when you do it locally. So the deployment is underway. Let's go back to our servers in Amazon. They are up and running. So now we want to connect, let's say we want to connect one. So I say connect. Then in the first instance, I need to get the password. Now, because I need to get the password, I need to specify that key. The key is there. Then the key, let me upload the key. Where did it go? Downloads. Download, that's the key. Open. So then I say decrypt password. Then it gives me the password. Then I say download the remote desktop file. So I can now connect to the server. And let me log in, then I share the screen with you, because let me close that. I put in the password, and then it's not working. Let me go to Azure deployments. I think I copied the password wrongly. Cancel. So So we're connected to the server that is in Japan. Just hold on, I share the screen. So we are now logging into the server in Japan. And are you able to see the screen?
Yes.
So this is a brand new server that we've set up. It's even asking us the same questions you ask when you set up a new server. So, and that's it. We are done. We have a server with us here, a Windows server, and we can do everything we can do on a Windows server. Let's see whether this server has access to the internet. There we are. www.yahoo.com. Yeah, it's on the internet. So this is an instance already. Now you can go in there and install whatever you want to install and run your services off there. If it's a database, if it's an application. So this is an example of platform as a service. Yeah, where you are given a platform, you install whatever you need to install in terms of the applications that are running. And the advantage of this is that if there is a need to patch up or upgrade this operating system, it's not, that will be the business of the cloud provider. So this is an example in Amazon. Let us do the example. It's the same thing basically, even on Microsoft. So let me share this screen briefly. So here we are with the instance that is running in Germany West, and the server is running. We have the details and the IP, and we can immediately monitor the performance, resources, disk capacity, CPU, and everything. So we can access it the same way we were connecting to it. We can RDP to it. We can SSH. We can stop and start the server in exactly the same way we did in Amazon. Yeah. So the choice of whether to go Amazon or Microsoft is dependent on your needs, and those needs might not be apparent to the ordinary person unless somebody properly analyzes what your actual IT needs are. Yeah. So let me share the screen for presentations again so that we continue. So is there any question up to there? So we've seen it's very easy to launch an instance and be on the cloud immediately. That was just a very simple basic example, but there's a lot. You can set up databases, you can set up the availability zones, you can set up the redundancy, the fault tolerance, you can configure who can access from where, you can put in access lists and rules. You can even link your cloud instance to your identity services. For example, if you have Active Directory, even if you have the Active Directory on the premise, you can use the Active Directory on your premise to manage the access of your resources on the cloud. You can also move your Active Directory from the premise to the cloud, and you can also use an Active Directory that is in Microsoft Cloud to manage services that are being accessed in a different cloud provider. So all those scenarios are possible. So we spoke of the biggest fear of moving to the cloud being cloud security. Now, the security of the cloud ranks top among many IT leaders, especially when migrating to the cloud. And the difference between cloud and why I'm very confident about cloud as compared to on-prem. In on-prem architectures, the security services are often a layer. Like you have your servers and everything, then you put a firewall somewhere in between. But in cloud, the security is woven into the fabric of the cloud architecture. You saw there we created a server. We needed to download the keys. The keys needed to be in my laptop for me to be able to access that instance. Excuse me. But on the cloud, the security is, as I've said, is fully woven, excuse me, into the cloud design, all the way from the virtual network that you create, the servers that you create, and the instances that you run there. Worth noting is that the security of the cloud belongs to the service provider. That is their responsibility. That is in terms of accessing the cloud. But the security in the cloud is your responsibility. As you saw there, I put in a username and a password. I might as well put password 1, 2, 3. That is weak security in the cloud. Yeah, so security in the cloud was my responsibility, but security of the cloud is the provider. That is very important. And by that, most cloud providers have what is known as a shared responsibility model. If you're in infrastructure as a service, platform as a service, software as a service, where does your responsibility end? If you're using infrastructure, then your responsibility as a consumer, the one in orange, starts somewhere in between network security all the way to whatever you're running. Because remember, as infrastructure as a service, you're given the platform, the servers, the hardwares, and all that. In platform as a service, your responsibility as the customer starts from somewhere in between middleware all the way up to the data and the application. So for example, if you go to Amazon, you set up the server that we've set up there, which is basically platform as a service there. So on top of that server, I might decide, because now I want to run a database, I might need to install middleware softwares, maybe connectors and all that to the databases and other third-party apps. That is my responsibility. The application itself, the way it's designed, who can log in, how login is managed, how it accesses other systems on the cloud, that is my responsibility. The data that is on that application is my responsibility. Yeah. In software as a service, the cloud provider will give you all the security up to the application. An example is Office 365. They provide up to application security. The data security is your responsibility. If you save files on Office 365 that are of a critical nature or should not be stored on the cloud, then you are responsible for ensuring the security of that data. It is not Microsoft's responsibility. Microsoft will only protect that Office 365 instance you're using from being tampered with or hacked or something. Yeah. So this is the responsibility model that is usually used on the cloud. And the other thing worth mentioning briefly is that when I've been mentioning throughout the whole session that there is need for organizations to ensure that their cloud architecture is well architected. And both Microsoft and Amazon have what are known as well architected frameworks. And these frameworks basically have 5 pillars. And these pillars help the designers make sure that as they design the cloud system or as they migrate to the cloud, they observe operational excellence in that the systems become more efficient and easier to run. There's no need of moving from on-prem where it was easier to run and to the cloud where it is more difficult to run. It should be easier. There's focus on security, protecting the information, the systems, and the assets that you're designing for. Then reliability, how critical are your systems to ensure that the uptime is maintained. That is one pillar. Then performance efficiency. You do not need to over-design or under-design. You need to design it in such a way that it can scale and be elastic. And then, of course, cost optimization. On the issue of cost optimization, it is important to eliminate unneeded cost. An example of unneeded cost is an idle server or a very large database instance that is empty. Or unneeded cost due to poor design, where you buy a database, but you do not buy enough capacity to read or write to it. So if you buy 1,000 instances of reading and writing, yet you use 3,000, the additional 2,000 will cost you more per instance than the 1,000. So you'd be better off buying 3,000, you pay less than buying 1,000 and consuming 3,000 and you pay a premium for the extra. That is what it means. So it's very important to observe these 4 pillars when designing, and that is why I've been insisting that organizations need to involve qualified persons to migrate or plan the migration and even do the actual migration to the cloud. Maybe worth mentioning also, again here on the cost optimization, many cloud providers offer services that can tell you which of your services are idle, which of your services maybe are not being fully utilized, and gives you suggestions. It can even tell you, by the way, we have audited your systems and we note that your purchase capacity is 50% idle. We advise you to redesign or minimize your utilization for cost savings. That's what they do. And this is one of the biggest propositions that cloud providers have. They tell you, you're spending too much on us based on what you need to do. Please reduce. That builds confidence and helps the customer view the cloud provider as a partner in the journey of taking services to the cloud. Same for security. If you have a password that has not been changed for very long, the security audit system will tell you these users' passwords have never been changed. Or you created 10 users and only 5 have been logging on to these systems. We advise you delete the other 5 because why are they existing? So those are things. Or it tells you, based on the way you're configured your systems, we seem to see that the root user is allowed to connect from the open internet. We discourage that. Please ensure that the root user does not connect from the open internet, but from specific IPs. That's just an example of what the security platforms do. So there are many services that these providers provide. And as I've said, you don't pay for these. You pay for what I'd mentioned, the compute, the storage, and the other services you don't pay for. Now, due to time, I would like to cover briefly serverless architectures. What is a serverless architecture? This is a style of programming for cloud platforms that's changing the way applications are built, deployed, and even consumed. Now, by serverless architecture, we mean that let's take a good example. Back again to the exam council. They have an application that will receive a query from Safaricom on an SMS that maybe has an index number. Maybe send your index number to 22028. And I send that, and it hits the National Exam Council server. And it processes that information, returns that info to my phone. Yeah. The application that was running all that operation is hosted somewhere in a server, which maybe was created by Exam Council as they moved to the cloud. However, it is not necessary to actually create a server like the one we created there behind for the Exam Council to do that. They can use what is known as a serverless architecture, and all they need to do is place that application on the cloud without configuring a server or anything. Then that application runs, and you will pay for only when that application runs. So if today there are 10 SMSs, then you'll pay for 10 instances of that application running. Compared to us setting up the server, the same way you set up that server that time, you see it says $0.2 per day. as I talk, I'm paying part of that cost as I talk, because that server is still running. Yet it's doing nothing. I was just using it for an example, and I'm paying. In a serverless architecture environment, I do not need to set up that server to process 10 SMSs a day. All I need to do is get that application and put it on the cloud. And when it runs, I pay. If it doesn't run today, 0 shillings. If tomorrow it runs 10,000 times and each time is a shilling, I pay 10,000 shillings. Whereas if the same were on the server, I would pay for that server for as long as it is on. By consuming services on the cloud, I don't mean you running applications on the server. It means the server being on. If it's on and you can access it, you're consuming it, so you pay. So serverless architectures have attracted a lot of attention because on top of moving to the cloud using the methods I've mentioned, there are more benefits on cost savings you can gain by going serverless. So instead of the exam council saying we need to design it in such a way that we have 2 servers that can serve our normal needs, then we can scale up and down depending on the needs. Even that scaling up and down might not be necessary. We might just say, let's go serverless, and we pay based on the amount of requests that have been met. And this serverless means it's running on the entire Amazon cloud architecture. So you can run very many scripts and very many requests without the limiting factor of your CPU running out or memory running out or your disk getting filled. Now, serverless architecture is not the same as containers, which I'll briefly touch later. Now, what serverless architecture does, you remember we discussed about this and the cost savings you gain. There's an additional layer. There's an additional layer which, just a second. There's an additional layer which we can add, which is called a function, where instead of having software as a service, we now have function as a service. So they are event driven, and by event driven, it means if, for example, the SMS is received is when it runs. In the case of having a server, we are paying for that server whether we receive an SMS today or not. And we are paying for that server when we receive 10,000 SMSs or 0 SMSs. So function as a service has been embraced. And when people talk of designing for the cloud, they mean more often than not designing serverless architectures. Any new modern design that is happening today on software is preferably if it's done in a serverless environment, because you don't need to do that. And then with serverless environment, the advantage is that the costs are significantly lower depending on what you want to do. Now, function as a service, of course, is provided by various providers. One of them is Amazon. IBM have one called OpenWhisk. Amazon call it AWS Lambda. I think you've heard of it. Microsoft call it Azure Functions. Google call it Google Cloud Functions. And there's another provider called Auto, which offers a function called Web Tasks. So you can go to any of these providers and run your services as opposed to running servers themselves. There's a video for AWS Lambda, but because of time, I won't cover it. But let me play it. I think it will make the concept clearer. Let me just play it, just hold on.
Is it by coincidence that all the providers are American companies?
It's because as we know it, the internet was basically American for a long time. It's only that now other providers are now catching up, like Alibaba and all that. But most of the internet, as we know, it is American. And I would say it's just a coincidence. Tell me if you don't hear the sound.
When you're building applications, you want them to deliver a great experience for your users. Maybe you want your application to generate in-app purchase options during a gaming session, rapidly validate street address updates, or make image thumbnails available instantly after a user uploads photos. To make this magic happen, your application needs back-end code that runs in response to events like image uploads, in-app activity, website clicks, or sensor outputs. But managing the infrastructure to host and execute back-end code requires you to size, provision, and scale a bunch of servers, manage operating system updates, apply security patches, and then monitor all this infrastructure for performance and availability. Wouldn't it be nice if you could just focus on building great applications without having to spend lots of time managing servers? Introducing AWS Lambda. AWS Lambda is a compute service that runs your backend code in response to events such as object uploads to Amazon S3 buckets, updates to Amazon DynamoDB tables, data in Amazon Kinesis streams, or in-app activity. Once you upload your code to Lambda, the service handles all the capacity, scaling, patching, and administration of the infrastructure to run your code and provides visibility into performance by publishing real-time metrics and logs to Amazon CloudWatch. All you need to do is write the code. AWS Lambda is very low cost and does not require any upfront investment. When you use AWS Lambda, you're simply charged a low fee per request and for the time your code runs, measured in increments of 100 milliseconds. Getting started with AWS Lambda is easy. There are no new languages, tools, or frameworks to learn. You can use any third-party library, even native ones. The code you run on AWS Lambda is called a Lambda function. You just upload your code as a zip file or design it in the integrated development environment in the AWS Management Console. Or you can select from a list of function samples pre-built for common use cases such as image conversion, file compression, and change notifications. And built-in support for the AWS SDK makes it easy to call other AWS services. Once your function is loaded, you select the event source to monitor, such as an Amazon S3 bucket or Amazon DynamoDB table, and within a few seconds, Lambda will be ready to trigger your function automatically when an event occurs. With Lambda, any event can trigger your function, making it easy to build applications that respond quickly to new information. To learn more about AWS Lambda, visit our website and you can get your first Lambda function up and running with a few clicks in the AWS Management Console. And with the AWS free tier, you can try Lambda for free.
So in a nutshell, that is what Lambda is. The difference, again, as I've explained, we won't go into this. In a traditional environment, you need a server to run most of the functionality. In serverless architecture, you do not need, as displayed here and as I've explained. Now, briefly, we're going to touch briefly on containers. I mentioned containers, and I said on the cloud, a container is basically that. It's a cloud container that runs the application that you or the system that you are running on the cloud within that container. And that container will now plug into the operating system or the cloud instance that you prefer to run on. And what containerization does is that it makes, other than just the ability to migrate services from one cloud provider to the other, or to be able to run your code without worrying about the operating system underlying it. When you run containers, they're also very fast. Starting and stopping containers, especially in very large environments, you would definitely need to run container your systems in containers. Now, by large environments, a good example is in Google. Your Gmail, your YouTube, and even when you search on Google, all those services do not run directly on a server. They run on a container. And what that does is that the ability to run systems in containers gives them much more flexibility and speed, from deploying systems to testing to designing, even to production. All that they can do that within containers very fast. Yeah. Now, when you end up having very many containers, you end up having a problem of managing those containers. Yeah. Let me go to this slide. Oh, sorry. And in that instance, you might need another software that will help you manage these containers, and those that is called container orchestration. I'll cover that later. But this diagram here clearly shows the difference between running a virtual machine, like the machine that we set up in Amazon. We'll run the machine with the operating system, and then we'll put our apps there to run. Yeah. In containers, the operating system belongs to Amazon or the cloud provider. What you need to do is have a Docker engine, which is basically a container engine. And then on it, we can put all our applications. Maybe this green one is the one that receives SMS from the user. Maybe this orange one is the one that now sends the results back to the user with what they scored. Maybe this one, this orange function, dark orange, is the one that now does the database cleanup to make sure the database is not messy or something. Just whatever function you want to write. So in these instances, in the container instances, you'll only pay when any of these apps run. When they run. If they don't run today, 0 shillings. In the virtual machine instance, we're already paying 20 shillings a day. That might seem like little, but if you're talking of a large and production environment, it's thousands of dollars sometimes. So in this instance, we might end up spending more. So it's always wise to ensure that your systems are designed in containers, and you can be able to move these containers around. Now, the software that manages all these containers is called an orchestration software, and one of the most popular ones is called Kubernetes. I'm sure you've heard of that term. Let me share a video on what Kubernetes does and how it's advantageous to use this orchestration software.
Digital transformation is driving the adoption of a new application development and deployment approach called cloud native. Container technology is the key enabler of this modern IT approach. But what is a container, and why is it so powerful? To use an analogy, let's take a look at a shipping container before we answer this question. The modern shipping industry standardized a set of container sizes, so no matter what's being shipped, the containers remain a constant size, so they'll fit on every container ship or truck. This practice significantly improved the operational efficiency of the shipping industry. The promise behind software containers is essentially the same. Containers are a solution to the problem of how to get software to run reliably when moved from one computing environment to another. A container image consists of an entire runtime environment, an application plus everything needed to run it. Code, runtime, system tools, system libraries, settings, all bundled into one lightweight standalone executable package. And multiple containers can be deployed on a single OS and share the same OS kernel. By containerizing the application and its dependencies, differences in OS and underlying infrastructure are abstracted away. Now, you can move your application easily from a developer's laptop to a testing environment, from a staging environment into a production environment, or from a physical machine to a VM in a private or public cloud, and always know that your application will work just right. Besides being readily portable, containers are also very lightweight and super fast. A container may only be tens of megabytes in size, and containerized applications can be started almost instantly. Due to these characteristics, containers serve as the basis of enabling the decomposed microservices-based architecture of cloud-native applications. As more containers are used, enterprises need orchestration tools to help them run these containers. Kubernetes is an open-source system for automating deployment, scaling, and management of containerized applications. It groups containers that make up an application into logical units called pods, nodes, and namespaces for easy management and discovery. Kubernetes builds upon over a decade of experience running production workloads at Google and has a large and active community contributing to it. It brings scalability, flexibility, and portability to applications and has become the leading orchestrator for running containers and building modern apps. Based on our deep expertise in delivering and supporting world-class enterprise solutions, VMware has been developing container solutions.
I think we'll pause that. They've started marketing themselves
to help our customers leverage this technology.
Now, as I've mentioned, what you're noticing is that what the cloud provides is the ability for an organization to move from their current setup, which is maybe an on-prem service, on the traditional IT setup, and continue to exist that way, but with time, modify or change their systems in such a way that they operate serverlessly or are containerized. Yeah. So for systems that can use serverless architecture, you make them serverless. For systems that you need to containerize them, which is nearly everything, you can now containerize, and you enjoy massive benefits in terms of performance and cost. So when we say that when you move to the cloud, it is not automatic that you gain cost or operational benefits. It's because if you copy paste what is on your premise and take it to the cloud, you might not benefit much. But if you re-architecture your setup in such a way that you embrace these new ways, which are being called cloud native, where the system is running in a new way, which wasn't there before on the on-prem system, then you stand to benefit. Now, the container orchestration tools, there are many. Amazon has theirs, Microsoft has theirs, Kubernetes is there. Kubernetes is the most popular and is open source. Google have theirs and many others. So it's dependent on what functionality you want. The most popular Kubernetes and Docker Swarm, which is a orchestration tool for Docker. So you can have a Docker containerization being orchestrated by Kubernetes. Yeah. It doesn't have, just because it's a Docker containerization system, it has to be run by Docker Swarm. It can be run by any of these. Yeah. Now, to close, there are very many legal and regulatory considerations on migrating to the cloud. One of the key ones is privacy, the second one is compliance, and the third one is security. Now, the cloud has the same way in an organization, like if you go to a bank, there are certain compliance audits, like there are IT systems audits that have to be done annually. So how do you do that on the cloud? That is where compliance comes in. Organizations such as Microsoft, Amazon, and all other cloud providers such as Google, they have their systems audited frequently by reputable auditors. And they also share a list of the compliance requirements that they've met in terms of security, in terms of privacy, and all that. And these are available online on the Microsoft website, even on the Amazon website. A good example is this. This is a screenshot from the Microsoft website. It shows some of the requirements or compliance requirements that they have met. And there are so many. Down there, bottom right, you can see GDPR, which is one of the most popular requirements that organizations have to meet these days. So if you're storing your data on the Microsoft cloud, the first question is, do those systems meet GDPR requirements? Then yes, they meet. Or any other requirements, Department of Defense, the ISO standardization certifications, and different industry certifications also. So all that info is available online, and it shows that the cloud is no longer just a place where people are afraid to go to. It's a place where people want to go to because of the benefits and the assurances that they get by moving to the cloud. And there's a lot we can talk about that. There are many other requirements, especially for a regulator environment, If the government, for example, of Kenya is adopting cloud, what global or industry or regional compliances do they need to meet? Yeah. Or if it's a bank usually has maybe standards. I'm not sure about them, but maybe let's just use as an example. Let's say the first one under industry. Maybe that is one of the requirements that an organization needs to meet as an institution. Then by going to Microsoft Cloud, then they are assured that that requirement is met. And these cloud providers provide this information, and even the audit reports, if you want them, they can share with you. They're available online, where you can download and see ISO certification guys came here and they conducted an audit on ISO 27001, and these were their findings. The same way an auditor would come and do the same in your on-premise organization. So it's very important to realize that the cloud offers all that. Now, I'd like to stop. I think we are done. Unless there are any questions, the floor is open for questions so that we can be able to address them. I apologize, I've taken longer than expected. Any question or query?
From this Haji.
Yes, sir.
I don't have questions per se on the content again. I think this could be for Stephen, Mr. Afralti. I couldn't trace the slides for yesterday on the learning platform.
Oh, yes, Haji, thanks for that. I think the presentation will be loaded today or yesterday and today, yes.
Thank you.
Any other question?
Hello.
Yes, hello.
This Maranga.
Yes.
Mine would be on time.